Hi, this is Jonathan. Welcome to part 2 of using dynamic routing protocols. We're going to continue our discussion of OSPF and BGP. Actually, I think we finished OSPF and we're going to get into BGP on this one. Again, OSPF and BGP. So what we're going to talk about actually is BGP. OSPF was in the last section of the dynamic routing protocols. And remember, as we said twice before, I think it may be 3, we don't recommend using routing protocols on the transport side. Remember, just use a default route into the WAN edge. Okay? Just so that, as we state, you can use BGP for all your service-side routing, and you can use it for your transport routing to enable communication between that vEdge and other Cisco SD WAN devices. We're not really going to run another routing protocol between these vEdge devices, other than OMP. There's really no reason to. OMP is going to handle everything we want to do. You may, however, and there's a high probability of this, is that if your vEdge device is actually your customer edge device, you're going to run BGP to the provider edge device. Okay? And if you're familiar with MPLS, and you don't need to be, and I know we mentioned that you should be able to spell MPLS in the beginning of the course, basically MPLS is multi-protocol label switching. It's a way of doing fast layer 2 switching in a WAN environment. A lot of providers use BGP for this CE to PE peering session. So you may, if we're doing a greenfield deployment or a brownfield deployment where the vEdge device is replacing your existing customer edge router, we will need to run BGP to peer with your provider edge. And that's an option for you if you don't have to do that. Some providers will just let you do a default route. The problem, of course, is if your MPLS provider doesn't provide internet access, or you have multiple internet access providers, having multiple default routes could get a little cumbersome. Okay, so we're going to configure this the same way. We're going to go in and go into configuration, and then we're going to configure another feature template. But this time, instead of collecting OSPF, we're going to select BGP. Okay, we're going to want to no shut it, and then we're going to we'll create an AS number. The AS number is going to be dependent on who you're connecting to. So if you're running iBGP inside your network, so if you want to peer BGP internally with a BGP router inside your network, we might run iBGP. Or we might run eBGP out to a provider for your provider edge if you're MPLS. Okay? But the AS number is really important. We're going to make this a variable, of course, for BGP, because at the end of the day, you probably only have one BGP instance on the router per VPN, or even totally. So we'll make that a variable. So we'll have one BGP template and apply it to the devices as we needed. Again, system IP is used as the router ID. We're probably not going to be able to do that if we're BGP peering with a provider edge, especially if our system IP is not a routable IP address. Okay? I recommend that you don't use your system IP as a routable IP address, so you can use that IP to easily identify the site. All right? Let's see. We also need to carry that AS path information into OMP. You're going to want to do that, so if you do BGP on the other side, that AS path information is carried with it. Okay? If you turn this off, you won't. And then you can change the admin distance for iBGP. It's 200 here. I would generally not do that unless you have a good reason to. Okay? And then the eBGP is actually 20, which is, these are all the standard admin distances that you're used to in Cisco routing and switching. Notice that it doesn't say iBGP and eBGP. It says external and internal. Okay? All right, and then we need to decide what we're going to redistribute. Obviously, we're going to want to redistribute probably OMP. Okay? And we can also create our own local route policy if we choose to right here. And we also have the option to advertise a local network prefix. Remember, basically, this is equivalent to a network statement in Cisco BGP configuration. Okay? And then we can create aggregate addresses as well, and enable a summary only option. If you do enable a summary only, obviously all the included subroutes will be suppressed. Right? Generally, we want to do this, especially if we own all of the routes in the summary address. Generally, if we don't want to do this, if we don't own all of them, we don't want to do that because, well, we don't want to advertise routes we don't actually own. Okay? And then we add a new neighbor, and basically we take its IP address of the neighbor, description, MPLS provider, whatever, and then our remote autonomous system number. All right? If it's eBGP, it's obviously going to be different. If it's IBGP, it'll be the same. Address family, we can turn that on or off if we want to, depending on whether or not we're doing IPv4 or IPv6. And obviously, we'll want to no shut down that neighbor so that we can actually peer with them. Okay. Again, I would leave these as variables. And that little thingy with the antenna on it indicates a variable. These indicate here that we're actually setting it here we're hard setting it. This is what this code means. We're hard setting it. If there's a little picture of a green planet, that means it's a global setting, and it's the setting that's going to be retained planet-wide. Okay. And here's what that looks like on the CLI. Again, this looks just, I mean, other than a couple of carriage returns you're probably not familiar with, it looks just like a Cisco router. So obviously, we're putting it under the VPN, so this is a service-side VPN. Router, BGP, here's your AS number. Here's a neighbor and its remote AS, and there's a no shut. Remember, everything's going to be shut down by default, so we're going to want to no shut everything we can find to make sure that it comes up. And there's the address family of IPv4, and we are to redistribute OMP. And then our OMP, we're redistributing BGP into it. Okay. And again, we can also attach route policy for each individual neighbor. And again, I would like to make sure you're aware of this. By default, OMP routes are not redistributed to BGP, okay? And vice versa. So if we advertise a bunch of routes to the SD-WAN router and we don't redistribute them, no one else is going to know about them, okay? Because remember, we're not running BGP or OSPF between vEdge devices. We're only doing it between vEdge devices and our inside network, and possibly to a CE router, a PE router, I mean. Okay. And then we can do the exact same thing. We go into monitor again. We can do it in real time, and we can do a BGP neighbors here, and we'll see whether our neighbor's up and up. And what we want to see is active here. Okay. Oh, and here you can also confirm the AS number and the IP address if any of these are actually turned off. And if we see zeros across here like this, this indicates we're not actually communicating together. Anyway, this one that might be most valuable is how long we've been up. You can see if we've transitioned recently. And we can do a BGP routes, and we'll show us the BGP routes in our next hop. These, of course, our next hop is our self. And the origin here is incomplete. That's not good. If we have an incomplete origin, there's a high probability we're not going to get into the routing information base. Okay? We'll talk about the routing table in a few minutes, and then I think a next section of slides. And when we do, you'll see that some routes are going to be showing up in your table, but not actually inserted. And we'll talk about why that happens. Okay. And then we have the same CLI commands: show BGP neighbor, and show a BGP routes, which are going to be the same ones. Yeah, that incomplete bothers me. You'll see why. This is probably from a lab. These screenshots are probably from a lab environment where they weren't actually really up. So. Anyway, let's see. Okay, so loops. Loops are bad. Generally, we fix them with a time to live value. But from a routing standpoint, a route is really bad. Loops in routing is really bad because we can advertise routes back and forth to each other forever. All right. So generally, it's a serious network problem. The network's going to continue to route packets within the network in an endless circle. A routing loop can have a catastrophic effect on a network, and in some cases, completely disable it. So a major portion of the limited bandwidth that is available for normal user traffic, the affected routers, is going to be consumed by these looping IP packets. And the major portion of the processing power of the affected routers is going to be used to process those looping IP packets. We need some kind of loop prevention mechanism. In OSPF, we actually have the down bit. And in a BGP, we have the site of origin community in BGP. Okay. Now, how do we do route redistribution and making sure that we don't have any in OMP? Well, basically, we're going to automatically redistribute the following types of routes that it learns from local or from its routing peers. Those connected routes. So basically, these individual interfaces back here are automatically going to get advertised. So if you're connected or we add any manual statics, that says connected. Static, okay, and those inter-area routes and redistribution of the following types are going to be requiring explicit configuration: BGP and OSPF external. Okay? And to avoid propagating excessive routing information from the edges to the access portion of the network, the routes that vEdge routers receive through the OMP are not automatically distributed into other routing protocols either. So OMP routes aren't going to come back this way either. So they'll hit this vEdge, but they're not going to get advertised there unless we specifically configuration. And as you noted before in the OSPF and BGP, we did specifically configure OMP redistribution into OSPF and BGP, respectively. And as you note, here we are, an OMP route redistribution to BGP and OSPF. All right, but we do have some automatic redistribution from vEdge service side routes into OMP. So OMP routes are redistributed into OSPF as type external with the DN bit set for loop prevention. That way they don't get advertised back into vEdges. That previously unused bit in that OSPF LSA options field is referred to as the DN bit, if you're not familiar with it. Bit basically set on types 3, 5, and 7 LSAs when routes are redistributed into OSPF. When the other edge router receives that LSA type 3, 5, or 7s, with that DN bit set, the information from that LSA is not used in the OSPF route calculation. So we redistribute the OMP into OSPF, but will not bring that OSPF route back into OMP if it gets to another vEdge, if you have 2 vEdges on a site. So for example, I learn a route via here, I advertise it into OSPF. I don't want to advertise it back this way, so it comes back that way as well, right? This prevents me, this guy from going, hey, you know what? I lost my route to here, but I'm getting it from this guy. And I route, that's bad. Don't let that happen. Let your DN bit handle the work. And this happens automatically. You don't actually need to do anything. We saw an option before about carrying that AS path information. Remember, BGP is a path vector routing protocol, all right? Which means I know which way to go, that way, and I know which vector it is. I know how many times I've gone through each AS, and every AS is listed in a path. I went through AS1, then AS2, then AS3. If I see AS2 again, I've already been through AS2, so now I know I'm in a loop, okay? So this is the way we verify loop prevention, our loop prevention works in BGP. I look for an AS path I've seen previously. So remember we saw that checkbox when we were configuring BGP about carrying AS path information in that OMP packet. Okay? So remember, when I propagate a route over OMP, it retains its origin information that it came from BGP and its AS path. Okay? So all that information comes with it. All right? So when BGP updates traffic through various ASs, eBGP routers prepend their AS to the AS path attribute. So BGP routers are going to again use this information to check through which ASs certain updates pass. If an eBGP speaking router detects its own AS in its AS path attribute update, the router ignores the update and does not advertise it further to iBGP neighbors because it's a routing loop. This is built into BGP. This is not specific to the vEdge environment. Okay? This has been around since Halabi wrote the book. I know, shout out to Sam Halabi. And then, by the way, in the SCLI, you'll see this config. It's also a checkbox on the BGP configuration feature template as well. Okay. So just to show you the difference here, this is with that AS path, and let me clear these out so you can see this diagram because we're going to do some comparison here. Okay. So this is our BGP loop detection. We came in with AS100. All right, and we advertised that to AS300. AS100 got that update with AS300, then 100. Its AS100 saw its own AS in it and killed that connection. With it turned off, it doesn't see that. It just sees it as a route and says, yay, it's happy, and puts it in the routing table. Okay? And remember, if you don't have that checked or this configuration in the system, right, we don't carry that information with us, and that AS path information won't be carried with us, and our ability to do loop prevention in BGP fails. So this is called a BGP site of origin. It ensures that loop-free network, in particular multi-home sites. And that site of origin is a tag that's appended to BGP updates to allow a peer to mark a particular peer as belonging to a particular site. Just so you know, I mean, just in some environments, the BGP AS path may not provide the granularity required in preventing the loop in a control plane. So that site of origin is designed to fill that gap and to prevent a routing loop that might occur. So remember, before we didn't carry that site of origin, so we're going to use this site ID number as our system for loop prevention as well. Okay, and then there's multi-exit discriminator as well if we have multiple options for BGP, if we're multi-homed. It's unlikely we're going to see a multi-home V-edge, but at the end of the day, they do make V-edges and C-edges that are pretty large, so you might see them as edge devices in relatively large deployments. So we might have a multi-homed BGP V-edge. All right, so basically we support standards-based OSPF and BGP. And we, just so you're aware, BGP and OSPF both have built-in loop prevention mechanisms, which are going to be necessary to make sure your network stays healthy. Thank you very much for watching, and stay tuned for more.